Good morning, ladies and gentlemen. I'm Chen Xi from Renmin University of China, and this is my first time to present on an international workshops. So it is absolutely an amazing experience for me, and I hope that I can put myself as clearly as possible. The topic I'd like to share with you today is about the welfare effect of mandatory policies. As a common means used by government, mandate has long been questioned whether it corrects consumer bias or distorts consumers' choices, especially in the field of energy and environment. Taking the heating energy transition program in northern China as an example, we try to estimate the real impact of this policy. Unfortunately, we find that mandate is not as effective as the government thinks, among which the problem of inequality stands out. Next, I'm going to use several slides to explain why we come to this conclusion. Well, in the traditional policy analysis, people are assumed as rational, but this is not always the case. It has long been suggested that consumers may be imperfectly informed about or inattentive to some costs when they make a purchase decision. Therefore, many policies are designed to address this distortion. Mandate is one of the important examples. It attempts to adjust consumers' behavior to the optimal state through legal and administrative means. Many studies have studied the efficiency of mandate, but come to different conclusions. Some discovered that it could indeed improve the total welfare, but others held the negative opinions. This paper focuses on the energy market, specifically the heating energy transition behavior in northern China. With the increasing pressure on the environment, households are expected to change their energy from dirty coal to clean gas or electricity. In practice, however, as coal is always cheaper, the spontaneous energy transition is always difficult. Government, as a result, use mandatory means to guarantee the substitution. To explore the actual effect of mandatory policies on welfare, we study the heating energy transition program in northern China based on the household survey data in rural areas in Hebei and the Beijing province. The remainder of this paper is organized as follows. Section 2 introduced the theoretical framework and background. Section 3 describes the model and data. Section 4 and 5 presents the results, and Section 6 concludes. Well, in Section 2, we want to answer two questions. Why is mandate popular, and what is mandate like in practice? First, we use two figures to explain the first question. In the heating energy transition process, consumers are faced with two options. One is coal, and the other is clean energy. As clean energy is often partially subsidized, we express their budget line as a blue one, this one in figure 1, and the budget line corresponding to coal is a black one. Q and N is the quantity of heating and the numeric, respectively. When a consumer doesn't realize the costs, such as the health cost, he assumes his budget line is the black dotted line. So he thinks the best choice is coal. In fact, however, the optimal choice is the clean energy. And mandate actually aims to correct this bias, to solve this bias. But what if consumers do not care about health, or the health cost is very small? Figure 2 displays this situation. In this context, their optimal choice is still to burn coal. So at this time, if consumers are forced to switch to clean energy, they will instead suffer greater losses in utility and welfare. The second question comes to the specific mandatory policies in China. In 2014, the Household Heating Energy Transition Program was piloted in Beijing. and later rolled out to 6 cities in Beijing, Tianjin, and Hebei region in 2015, and further extended to 28 cities in this area. The number of households participating in the project increased from 194,000 to nearly 7 million from 2015 and to 2017. And Hebei province stands out in the total number and in the increasing speed. The heating energy transition takes the form of a mandate to ensure the implementation. These mandatory policies can also be divided into 2 types. The first one is a milder measures, and the second is the strict measures. As we can see, the mild measures include door-to-door inspection and punishment. And strict measures include confiscating the coal stoves or prohibiting coal sellers from entering the village. It is easy to see that the strict measures directly kick the coal out of the selection set. And when these households were asked if there is no mandate and other conditions remain the same, only 55% said they were still willing to participate in the transition. Given the heating energy transition behavior is a discrete choice, we take the discrete choice model, DCM, as the basic model in this paper. The household's utility consists of observable utility V and unobservable utility. The observable utility is determined by both option attributes and individual attributes, which is X and S respectively. And the optional attributes is composed of 4 variables. That is facility cost, heating cost, warmth degree, and the mandatory degree. When households choose different energy, the values of these 4 variables change accordingly. Specifically, when the option is bulk coal, the variable comp equals to 1 if mandate is implemented, and it equals to 0 otherwise. When option is clean energy, the adoption of mandate will not affect households at all, so the value equals to 0 all the time. The theoretical basis of DCM is the utility maximization theory. Therefore, the welfare of household N can be expressed as Wn, and the expectation can be expressed as EWN. We use the superscript to distinguish between before and after the policy. Thus, the change in household welfare brought about by the policy is as follows. As we discussed before, there are 2 types of mandate, and the stricter one kicks the coal out of the selection set. So the welfare changed can be further expressed as the following 2 forms. The left one corresponding to the mild measures, and the right one corresponding to the strict measures, where some variables are simplified according to the definition before. As for the data, we use the household survey data in Hebei from CRECS, led by Renmin University of China. In a total of 550 valid questionnaires, there are 251 samples participating in the transition, and 243 samples have not yet. For the participants, we asked for their real optional attributes and individual attributes, but for the non-participants, we use a scenario experiment to investigate their energy choice behavior. This table shows us the participant rate in different scenarios. Based on the model, based on the model and data, we can come to the results in section 4. As seen from the option attribute table in section 3, if no mandatory measures are taken, the value of mandatory degree is 0, otherwise is -1. So the regression results shows that mandate can indeed increase the probability of households' participation in the transition. Other option attributes such as facility cost, heating cost, and warmth degree are also significant at the level of 1%. The higher the equipment cost and the heating cost, or the lower of the warmth degree after the transition, the more reluctant the households are to participate in the transition. Based on the regression results, the relative utility before and after the mandate under different conditions can be estimated, and then the welfare effect is calculated. As we can see, mandate significantly reduces the welfare. For the 251 participants, the mild measures reduce the welfare by about 1,571 yuan per household, and the loss rises to 2,300 yuan per household with stricter mandate. And for the 243 non-participants, stricter mandate also causes greater losses, about 43% to 137% higher than that of mild mandate. Besides, the higher the cost of the participant or the lower the temperature, the greater the negative impact of the mandate. The welfare effect may also differ across different income groups. We use a dummy variable to represent income groups, and the results show that mandate has a greater impact on low-income groups, as clean energy is more expensive for households in this group. But in the table, we can also see that the impact on high-income group, which we think that may be due to their lower monetary marginal utility and higher reciprocal of RFN. Furthermore, we select cities with different income levels for comparison. We use the household survey data in rural Beijing in 2017. The basic conclusion, we can see that it doesn't change, and the mandate will cause greater welfare losses to households in Hebei with lower income. As discussed before, the mandate reduces the utility of households in terms of the behavior distortion. However, as it indeed increases the participation, some unrealized gain is also achieved. From the perspective of households, mandate can reduce indoor air pollution and thus increase their life expectancy. We use the human capital method to evaluate the health gain, where the benefit is closely related to the income. The results show that the improvement of air quality can only bring an annual health benefit of 3,000 yuan per household. This gain is higher than the
five minutes.
Okay. This gain is higher than the utility loss of households who have participated in the transition, but lower than that in the scenario experiment, especially when the mandate becomes stricter. As a household in transition usually enjoy government subsidies for the purchase of heating facilities, which reduces the estimated utility loss to some extent. The health benefit of the policy is actually not enough to compensate for the utility loss induced by mandate. And with health benefit related to income, we can see that low-income group will get less health benefits and suffer more loss from mandate. And from the perspective of the society, it is undeniable that the environmental benefits at the social level have also been realized by forcing households to use clean energy. We measure the value of environmental benefits as about 5,000 yuan per household. However, the improvement of social welfare is based on the loss of households' welfare, especially at the expense of the low-income groups. Besides, mandate also has a cost at the social levels, such as the manpower or the supervision cost. We don't get this information to quantify this cost in this paper. And if they were taken into consideration, the effectiveness of mandatory policies from the perspective of society will be even more questionable. Above all, in the energy transition program, mandate can indeed bring about health or environmental benefits, but it is at the expense of household welfare and unfriendly to low-income groups. So we suggest that the government should try to avoid using mandate to change households' behavior in the program implementation. And areas with a high level of development should first engage in the transition. Households with very low income can also be protected by means of transfer payments. In the future trend of subsidy reduction, the losses caused by mandate will become greater and greater. It is necessary for households to make the energy transition by themselves, which can be achieved by raising their awareness of the importance of clean energy through measures like publicity and education. This paper is still under revision, and we appreciate any comments. Thank you.
Okay, thanks for the nice presentation. And now I pass the floor to Leonardo. Leonardo, you have 5 minutes for questions and comments, and you can share your slides. Okay,
yeah,
thank you.
So thank you, Chancy, for your great presentation. I'm wondering, can you see my screen right now?
Yeah, I can see that.
Okay, so given that I have only 5 minutes, I'm gonna go straight to the questions. So the first question is related to this variable, to this dummy variable that is called comp.
Yeah.
Probably something that I didn't read well in your article, but initially you say that this variable is defined as a 1-0 variable. But when you get your result in your probit and logit model, you get a negative signs on the coefficient of this comp variable. And you say in your article that the interpretation now should be 0 minus 1.
Yeah.
So that is my first question. Is something that I didn't read well, or is there a mistake there? The second question, Shensi, is related to the reduction in the temperature after the transition. I'm wondering, how do you measure that reduction in the temperature? Is there like, let's say, an instrument like a thermostat, or is basically measured by people perception about this temperature reduction? Also, I have a question related to one model in which you decide to incorporate these 3 dummy variables that capture the income level. You define 3 dummy variables, the low, middle, and high income level. And after that, you incorporate these 3 dummy variables in your model, and additionally, you add a constant there. So I'm wondering about the collinearity problem and the standard error, because normally when you have this kind of behavior in which you decide to incorporate the 3 dummy variable plus the constant, I would say that in a logit and probit model, probably you're gonna get the estimation of the coefficient, but probably there is a problem there with the standard error. So I'm wondering, how did you deal with that problem? And finally, and probably this is the most difficult question to answer, and actually I don't have an answer, is related to the endogeneity and exogeneity problems. Because if you think in your model, let's say that there is an increase in the household participation, and let's assume that there is no, for instance, government intervention. One will expect an increase also in the price of the heat cost and the facility cost at the same time. So it seems that there is also a kind of a bi-directional feedback mechanism in your model. So I'm wondering, what can you say about that?
Okay. Yeah.
You can answer his questions, and we'll have follow-up questions from other participants. So you can answer his questions.
Yeah. Okay. I can first answer the second one because it is more. It is easier for me. When we measure the temperature, we mostly use the people's perception. So we will ask them do you think that it will become colder when the energy transition? Yeah, we use this to measure the temperature change. Yeah,
Okay.
and yeah, and for the third and fourth question, yeah, when we do the analysis, we indeed we didn't consider about the endogeneity problems. That's what we have to, you know, improve our paper later. And for the first question, because I have said that the 0 or 1, but there is how can I say that? Because we do a we did a because we are measure the change before and after. So if after the transition they use the clean energy, it is 0, and before it used bulk coal, and they use bulk coal, the result will be 0 plus 0 minus 1, and it comes to -1. I don't know if I can explain it clearly, but yeah.
Yeah, I think I can understand that, but probably it will be better if you write down that in your article better, because for me it was a kind of confusion when I saw the table number 6, and after that I say, but why they decide to change the 1 to a -1?
Yeah.
So
Yeah.
okay.
So later we will express it more clearly in our paper. Yeah. Thank you for your suggestion.
Yeah. So thank you, Shansi.
Okay.
Okay, thank you. If maybe I have some 2 questions. One is related to like the sampling. You have the participants for the stricter and for the mild mandate programs. So we have maybe in presentation, because of time, you haven't explained well about the sampling. So how are the participant allocated to the mild and to the strict mandate programs, and also the inclusion of rural and urban households? Do you have data, like can you say how the behavior when you compare rural and urban? Can your data say something about rural versus urban? Thank you.
You mean what is the difference between the strict measures and the mild measures?
Yeah, yeah.
We think that strict measures, it means that it likes where the government directly kick the coal out of the selection set of the household. It's like if you confiscating the coal stoves of the households, they can't use coal anymore. But if you just door to door, you just door to door to check if they use this, if they use coal, and if you find that they use coal, you will punish them by fining or something. You can after you leave, they can still use coal. So we differ these 2 measures by if coal is totally out of the option set of households. Yeah.
So these 2 are not in the same place; they are in different places. Yeah, like in a one village.
Yeah, they maybe differ across villages, because one village will just use one.
Okay. So do you use cluster standard errors in that case?
What? Sorry.
Cluster. When you use your standard errors, have you clustered your standard errors by village, or is it household?
Yeah.
Okay.
We use.
Okay. Other questions? Okay, thank you, Chen. So we will move to the next presentation.
Okay, thank you.
The next presenter is Ashish Sadai, and I am the discussant for that. So Let's welcome Ashish.
Thank you so much. Let me just share my screen here.
Yeah.
Uh, okay, can you see the screen here?
Yeah. Yes.
Okay, great. So it's visible for everybody. Okay. Thank you very much, and thank you for participating in this presentation. uh, the paper that I'm going to present is Electrification and Welfare for the Marginalized, Evidence from India. And when I say marginalized, I mean the social marginalization in India. This is a co-authored paper with my colleagues from University of Copenhagen, Colorado State University, and University of Wollongong. Uh, this is a paper in a chain of 3 papers we wrote on electrification, reliable electrification in India. And in this paper, what we want to see is socioeconomic disparities between dominant and the marginalized groups in India. So when we say socioeconomic disparities between marginalized and dominant groups in India, we want to see the caste effects of electrification, basically. For those who are not very familiar with the caste aspects in India, this paper might be a little difficult to understand, but I'll try to move along with the lines of social and ethnic differences as well. So socioeconomic disparities between dominant and marginalized groups has been widely documented in India. There have been affirmative actions, but still the persistent socioeconomic differences still exist. Marginalized groups face a higher risk of falling into poverty because of the vicious cycle of poverty that the caste system really entails in India. In that context, what we wanted to see was, does infrastructure, like basic infrastructure such as electricity, lead to equitable development or not? Between 2005 and 2018 is the data set that we use. And we have a strong policy impetus by the central government from 2003 onwards in increasing electricity access for all in India. And when we say electricity access for all, the electricity provisioning policy in India from 2005, especially with the Rajiv Gandhi Gramin Vidyutikaran Yojana, was providing electricity to all regardless of income levels. It was a subsidized way of providing electricity because of the eminent issue of not having electricity and not having reliable electricity in India. Uh, so the question then that we are trying to address is, if a government scheme is for all, does it mean it becomes more accessible to the marginalized? Because a priori, we believe that the marginalized groups are the one who are more discriminated in access to water, electricity, credit, etc. So, and then the consequent question that we also ask is, even if you have electricity, are there other kinds of barriers that restrict you from using that electricity for welfare gains? And I will talk about what welfare gains we are discussing in this paper later in other slides. So with that, I move to the next one. Uh, Studies have shown that scheduled caste and scheduled tribes in India, which are argued to be constitutionally the ones that are marginalized the most in India, although other backward castes are also considered marginalized. But for our purposes, we just focus on scheduled castes and scheduled tribes in India. Shows that scheduled caste, scheduled tribe people have 14-15% less likelihood of receiving electricity. Other studies show that villages with marginalized populations tend to have lesser access to electricity as compared to villages that have dominant groups as majority. Other studies have also shown that in some states, the likelihood of electrification for marginalized groups, also called the Dalits in India, is 20% less likely than that of villages without Dalits. So in that respect, we see that there has been a huge difference or inequality in access to electricity between the marginalized and the dominant groups in India. And that is what we are trying to address here. But on papers, the issue is more interesting, because in papers, what we see is hours of electricity supply in India depend on the village feeder. In other words, if you want to understand it, like the transformers set up in the villages is what distributes electricity. And so the transformer per se does not difference between marginalized groups and the dominant groups. But literature has shown that SC/ST households kind of consume less electricity than other dominant groups. Disadvantaged households are less likely to be electrified. And very recently, one of the papers that really prompted me to go into working on this paper that we have written here is this study by Pels 2020, which was published in World Development, shows that in the 6 states in India, major populous states in India, which have the highest populations and highest levels of poverty in India, between 2015 and 16, they used panel fixed effects to show that marginalized groups did not receive any increase in electricity as compared to dominant groups. They just said that marginalized groups and dominant groups kind of received similar increases in electricity, and there was no significant additional likelihood of electricity for marginalized groups. I kind of thought that why would this be the case? If an electricity program is universal in nature, and if the marginalized groups are the ones who do not have access to electricity more in comparison to dominant groups, then a public policy which is universal in nature should be affecting the marginalized groups more than that of the dominant groups. And so then we also thought of other questions, not only about getting electricity or getting electricity connection, the dummy of electricity connection. We started thinking that electrification does matter, but it is only a means to welfare. It does not really guarantee that having electricity means welfare. The ability to utilize electricity for welfare gains may vary by social groups. There are social constraints to use of electricity because the cultural patterns and traditional beliefs related to how to use electricity, when to use electricity, for what to use electricity. And so marginalized groups may be blocked by these constraints in their ability to utilize electricity for welfare gains. And so the question then also becomes, does electricity benefit all social groups equally? Or are the forward caste, when I say forward caste here, I mean the Brahmin, the Kshatriyas, mostly the Vaishyas in India, given their social clout, are better able to utilize electricity for gains in consumption, assets, and living standards. This is the welfare measure that we're going to look at in our study. Now, moving forward to the data that we use panel data for our analysis. We use the waves from 2005 to 2012 of the India Human Development Survey. And then we also use the Access Survey 15 to 18 for the 6 populous and poorer states in India. However, we have a caveat in our data analysis, and that is that Muslims also belong to scheduled castes and scheduled tribes in India and other backward castes in India. But the IHDS data does not really have this distinction of Muslims falling into scheduled castes and scheduled tribes. So for analysis, we have 3 groups that we are trying to look. The first one is the Hindu forward caste and OBC. The second one is the SC/ST Hindus, and then we look at Muslims separately. We do the similar analysis. For the Access Survey, we don't need to do that because the Access Survey also puts Muslims into SC/ST categories as well. The other caveat is that the India Human Development Survey has only 83% of the sample matched. So we have certain observations. When we regress, we don't have one-to-one match in fixed effects. In the Access Survey, we have this 95% match. And electricity access is derived from the survey question, which asks households, do you have household electricity access? And if yes, how many hours do you have it on a typical day? These are the 2 main outcomes as well as regressors that we use in our analysis. Moving forward, if you just look at this figure, I know this figure is a little old. It's from 2012, and there have been claims right now in 2020 that all of India has been electrified, and then electricity access and electricity hours are now up to 24 hours in a day. But the definition of electricity access in India is very skewed and very misunderstood, in the sense that it is argued that if a village has 10% of the households that has electricity, then the village is considered to be electrified. I have personal problems with that kind of definition with electrification. So I'm just moving back to 2012 data to show you that there has been massive inequality and massive lack of electricity hours in India across all states. It's not only a few states that have less access to less hours of electricity on a typical day, except for states in Punjab and Gujarat and certain areas in Kerala or certain areas in Madhya Pradesh. You see that there has been a lack in electricity hours across India over time. Then another interesting aspect of that we really found out when we were doing this analysis is that I mean, it's hard to believe that once you have electricity, somebody is going to take away your electricity hours. Suppose you in 2005 you had 15 hours of electricity in a day, and in 2012 it comes down to 13 hours. So this is something very hard to imagine, but this is the fact in India that has happened. As you can see, for all social groups, forward caste, OBC, Dalits, Adivasis, and Muslims, there has been kind of a redistribution in electricity hours. While some households gained electricity hours, some households tend to lose electricity hours. And the same is true for 2015 and 18 also. So there is no guarantee that once you start receiving 16 hours of electricity that you will only progress further. You might even regress in terms of electricity hours in a day. And so this issue is more important from a social discrimination point of view, because you would expect that the Dalits would be the ones at the losing end mostly as compared to the forward caste in this context. Here again, we see that between 2015 and 18, there has been a gain. There has been a sharp gain in electricity hours. And for all social groups, there has been a gain, but that does not in any way imply that there has been no redistribution of electricity hours. Moving forward, another thing that is interesting is that if we only look at a pooled cross-sectional model, then you will see that if you are a poor household, then there is a lower likelihood of having electricity. Just being the poor effect on the social group is higher for the marginalized groups as compared to the dominant groups in terms of access to electricity. Now, moving forward with those things in mind, what we do is we set up an empirical model, a very interesting empirical model following Pell's 2020 again, where you'll see that this 2012 is the coefficient for all groups in 2012. So imagine if we have a 10% increase in 2012, that means the 10% is the baseline for the dominant groups as well as the marginalized groups. And whatever is this coefficient that we're going to see in caste, if we add alpha plus delta, then that's the absolute change for the SGST groups, for the marginalized groups is what I mean. So I will be explaining more in the table later on when we show the results. But this is the basic specification for what we are going to do. If you have any questions, I can answer on this again later on. And then we do the same analysis for Muslims again. Interestingly, we tried something new in this paper, in that we don't really use an instrument for caste. We in fact use an instrument for one of the important predictors in the model, which is consumption expenditure. Following Saxena and Bhattacharya, we use ownership of motor vehicles as an instrument for consumption expenditure to control for the endogeneity between consumption expenditure and access to electricity.
You have 8 minutes.
Yes, sorry. Okay, oh my God, we don't have time. So then we use panel fixed effects. I'm just going to rush into the results now. First of all, you see that the SCST Hindus had 5.9 percentage points higher likelihood than the dominant groups to receive electricity in between 2005 and 2012. The general groups had 11.5% likelihood of receiving electricity, higher likelihood of receiving electricity, but the dominant groups had even more. The same thing exists even when we take fixed effects as well as we take IV fixed effects. And here also you can see IV fixed effects shows that for Muslims versus Hindu SC/ST groups, there is a slightly lower access to electricity than for Muslims as compared to Hindu SC/ST groups. Next, we look at the same thing in rural urban areas. We see that the rural effect is stronger than the urban effect. For Muslims versus SC/ST Hindus in urban areas, it seems that the Hindu SC/ST groups kind of received more access to electricity than the Muslim population over there. Muslims versus the forward caste, Muslims tend to benefit more. Then we look at hours of electricity. I showed that in between 2005 2012 there is a massive redistribution of electricity. Some households tend to lose electricity, so the overall average effect was a loss in electricity. But the SC/ST Hindus kind of had a lower reduction in electricity hours as compared to dominant groups, which is interesting to see. Muslims versus SC/ST groups Muslims had lower likelihood of having lower electricity hours. I'm moving forward again, and then the same kind of an effect we see in across rural urban areas as well, where Hindu SC/ST groups kind of reduced electricity hours, but lower than the reduction for the dominant groups. And this table shows the effects across all regions in India. And you see that SC/ST groups kind of received highest gains in the east and the west as compared to other areas. And in terms of electricity hours, also the reductions were lower in, say, in the central plains, but in some areas, Hindu SC/ST groups and Muslims kind of reduce electricity hour than other groups in that region. Here, I'm trying to now move into the effect of electricity on assets. You see that electricity access kind of increases assets for forward caste, for SC/ST Hindus, and for Muslims also. But we kind of see that the effect is strongest for urban Hindus, forward caste Hindus, and then for Muslims, and then for the SC/ST groups. Similarly, the effect of electricity hours is kind of stronger in rural areas for SC/ST Hindus, but for forward caste Hindus, it's stronger in both rural urban areas. For Muslims, there is kind of no effect. This is for consumption expenditure. We see again that electricity access kind of benefits more the forward caste Hindus and the Muslims as compared to Hindu SC/ST groups. Similarly, for Hindu SC/ST groups, the electricity hours kind of matters more. And in terms of poverty, here again, in terms of poverty, the effect is strongest for upper caste Hindus in rural areas. Then the Muslim population is very strong again, but for SC/ST Hindus, the effect is lower again here. And now this is the robustness using the access survey. When we use the IB model, we see that there is a 2.4 percentage point higher likelihood of the Hindu SC/ST groups, all the SC/ST groups to receive electricity as compared to the forward groups. So in conclusion, what we're saying is our longitudinal study, in contrast to previous cross-sectional studies, shows that RGGBY and DDU-GJY, these are two public programs, did increase electricity access for marginalized groups as compared to others. The FE model shows that Hindus were 6.7% more likely to get electricity access between 2005 and 2012, 1.3% between 15 and 18, and IB model shows 2.4%. Marginalized groups were able to use electricity access to increase their consumption levels and also transition out of poverty. But the effect of electricity access and reliability was smaller for marginalized groups as compared to other forward caste groups. So we say that even if after having electricity and more electricity hours, there are other social variables, there are other variables at play which are not allowing marginalized groups to use electricity as much as dominant groups for welfare gains. Thank you.
Yeah, thanks for the nice presentation. I am the discussant for this paper. I enjoy reading this paper. It's an important paper, in particular for India, having this caste system. Particularly, it could be also important for neighboring countries where the caste system is more common. Okay, maybe I can share my slide. Okay, do you see my slides?
Yes.
Okay. Okay, before these comments, maybe I have some, one comment, like for someone who is not in India and not familiar with the caste system, and when I read the paper, first I had a difficulty understanding which of the caste is dominant and which of the castes are marginalized. So probably in the introduction part on the first page, it will be good to explain this is a dominant caste and these are the marginalized caste. And having said that, also in the introduction, it would be good to also have more stories about, you have mentioned some electrification programs that could benefit this marginalized program. It would be good to explain more in detail, not in detail, but somehow which could give a lesson to the reader, a clarity of these programs. And because of time, I will move to the critical questions, which I think are important. In your method section, in particular, a discussion below the equation 2, you argued, obviously it's true, consumption expenditure is indigenous and it's one of your covariates. You want to instrument it. And when I read it, you like an explanation of why is it indigenous. In the beginning, it's more of an explanation why your dependent variable, which is about electrification, it looks like why that dependent variable is endogenous. It should have been an explanation why your consumption expenditure, why is it endogenous? You explain more about electrification is not random. Because it's not random, you have it as a dependent variable and you have the control variables, the cost, other control variables. So I may read incorrectly, but it will be good to see or to hear your reflection. Why do you prefer to explain of your indigeneity in terms of the dependent variable? And second one, on the instrument by itself, ownership of vehicle. So we explain it affects the dependent variable indirectly, but affects consumption directly. But since vehicle is an asset, because in one of your regression, you have the impact of electricity assets on asset ownership or assets. And vehicle is one of the big and probably compared to a house, a highly valuable item. So it could be one of the direct factor. And I feel that it may not be a strong instrument. And on the result section, there is maybe it could be different. I mean, the ownership vehicle in India, it could be a different story. So I would like to hear your reflection. On the result section, yeah, there is a difference. You show that through different tables among the different marginalized difference in marginalized groups. So it's just a recommendation. It would be good also to complement if there are stories that are being discussed, for example, why one caste group is, for example, in comparison between Muslims and the other caste groups, the Muslims get less of electrification, in particular the reliability. So is it kind of an issue of discussion in media or in the country? So probably maybe important to complement stories that could go with your results. And last, what do you think is a lesson for other developing countries? Thank you.
Thank you so much. Definitely, I would like to start with the issue of endogeneity. We use the instrument ownership of motor vehicles only when we do the analysis of electricity as an outcome, where electricity is the dependent variable, not the independent variable. And so when we use that, we want to control for consumption expenditure, which could be correlated with electricity. Like you said, when we take the when we look at assets, in that model, we do not use any instrument. We just use panel fixed effects in the model because we understand that there is a collinearity and strong correlation between motor vehicle ownership and asset ownership as well. So I hope that that kind of addresses point 1 and 2. And then you said there is a difference in the extensive margin among the marginalized groups. It would be good to complement these stories if this is actually an issue of discussion in the country. Yes, for long there has been this argument that Dalits do not receive adequate basic infrastructures in comparison to the dominant groups. And so that is one of the reasons why we wanted to really dig deep into this question and see, does a universal program help, is the central question in this paper. The lessons for other developing countries, say developing countries in Pakistan, there is some kind of social discrimination there. Strongly in Nepal as well, because Nepal has this, it does not have this specific caste structure, but it has this marginalized, non-marginalized sections in Nepal itself. So for the South Asian countries, this paper could be an important contribution in understanding how a universal program could help.
Okay, thank you. We have some 3-4 minutes. We can accept other questions.
We have questions from Deepen. The first question is, I wonder what is the policy implication of this study? Should policy be formed targeted based on caste? One of the strong policy impetus of these studies is that any universal program that targets not only a certain section of the population, if, for instance, now what I'm researching on is water. And in 2009, the government of India started this National Rural Drinking Water Program, which was universal in nature, started giving water not to communities and villages, but to households. And I saw that this also led to an increased water access for scheduled caste, scheduled tribe groups. So in that respect, the policy implication is that any universal program which is subsidized in nature in India could actually benefit the marginalized groups in comparison to the dominant groups. The next question is, SC in India tend to live in similar regions as forward caste, whereas STs often live geographically different regions. Do you see any effects that point to this difference and the implications of being geographically scheduled in your results? Thank you so much, Krishna Priya. That is an excellent question. And I will try to dig deeper into that. You are absolutely right in saying, for instance, a lot of STs live in northeastern states in India. And so it is the thing about IHDS and Access Survey is that they don't really capture Northeast very well. They do capture the MENA STs from Rajasthan and other STs from Madhya Pradesh mostly, and Andhra Pradesh also, but it doesn't really capture the Northeastern aspect of it. And I will try to see if there is any other data set that could really address that question.
Just
Patrick,
to add to this question, you can actually look at geographical seclusion within states, especially Madhya Pradesh, Chhattisgarh, and all these states, because often within states as well, there is some amount of seclusion. And I don't know how you may capture it depending on your data availability, but I think it's worth looking at.
Thank you so much. Thank you so much. I think there is this variable in IHDS which asks at the village level, what is the most dominant jati in your village? So I can look at within state seclusion as well. Yes. Thank you so much. Patrick, you asked, why do you see decline in access to electricity in general after the electrification program? We don't. The decline is in electricity hours, not access. There is no decline in access. There has been an increase in access, but in terms of the hours of electricity, there has been a massive redistribution. The question of why it could be so is because when you give electricity to people without increasing the infrastructure, it is only going to lead to redistribution. That is what we presume might be the case. Although there has been an improvement in infrastructure, but the promise and the delivery is not really coherent, which is why there might have been redistribution of electricity, as also argued by other economists. And Krishna Priya, to what extent the political economy within states affects the access and quality of electricity to marginalized groups? There is a fantastic paper by Burgess et al. In 2020 in Journal of Economic Perspectives. The question is, what is the consequences of treating electricity as a right? Burgess 2020, that question really answers your question here, but in this paper, we don't really deal with that. And then there is a paper by Joseph in 2010 in Energy Policy. You can also look at that paper that might help you answer your question here, but definitely our study does not answer that question.
Okay, thank you very much. We move to the next presenter. If any one of you have questions, you can put down your questions and then he can, or you can communicate with him. Okay, the next presenter, Matthew. Energy insecurity influences urban outdoor air pollution levels during COVID-19. And the discussant is Patrick. So the floor is yours, Matthew.
Great, thank you very much. I'm just going to share my screen now.
चलो खाना खा लो माँ, आप ऐसे मत करो. Fast की हुई आप.
Okay, so thank you for the opportunity to present at this conference. I'm going to be discussing the impact of energy insecurity or energy poverty during COVID-19 lockdown in South Central Chile in the city of Temuco. So in air pollution assessments in epidemiological studies, we typically will focus on PM 2.5, which is particulate matter that is less than 2.5 micrometers. And in this slide, you can see that we target this particular metric because PM 2.5 is small enough to travel deep into your lungs, whereas larger particles such as PM5 and PM10 can get filtered out before they get into the lungs. And this is a very small particle, much smaller than the size of a human hair, so you can't see it. But we typically will monitor for these settings using different techniques. And so the reason why PM 2.5 is important is because it's used as a metric in the global burden of disease studies, which some of you may be familiar with. The top or the most, the highest burden in terms of environmental risk factors is actually ambient particulate matter. And then third on the list is household air pollution, which would be particulate matter found in the household. And household air pollution is particularly generated from cooking, heating, and lighting, something we refer to as polluting fuels, which can be biomass, such as wood or charcoal. And then in some cases, kerosene is used as well. And so, as I mentioned, this is a top environmental risk factor and estimated to contribute to almost 4 million deaths in 2019, which is the most recent global burden of disease. And so cooking with polluting fuels is more common in other areas outside of Chile, most commonly sub-Saharan Africa and parts of Asia, but it is still practiced in parts of South America as well. But in terms of this study, we'll be focused mainly on heating. And I have a picture here on the bottom right of a common type of stove that would be found in Temuco. So discussing energy poverty and the role it plays in air pollution. So about 80% of the population uses wood for heating. And as I mentioned, this generates unsafe levels of PM 2.5. And in some cases, though, in the winter months, when wood heating is most needed, households will actually refrain from heating to cut costs in some cases. So there's been other research that's been done that's shown that households' temperatures indoors can be much below 21 degrees Celsius in order to save on energy costs. And so that's also a cause for concern. And so I have here this graphic. This was taken from the Ministry of Environment in Chile. So this is in Chilean pesos, but you can kind of see differences in the different costs of fuels. So on the left, the cheapest form here would be a certified wood stove or wood pellet stove. And then as you get to cleaner fuels on the right-hand side, you can see here, this would be like a gas stove or electricity, how they're 2 or 3 times the cost of using wood, which is why, one of the reasons why wood is still commonly used. So then, because of the high prevalence of wood usage, Temuco is kind of an anomaly to other urban cities because wood burning is the largest contributor to outdoor air pollution. And so although we consider it as part of household air pollution, we know that this air pollution gets dispersed and distributed to outdoor as well. And so other research has shown that close to 90% of ambient air pollution is due to the burning of wood, as opposed to transportation or industry, as you can see from this graph on the left. So this is very different from other cities. And so further onto that, research that's been done looking at the impact of COVID-19 lockdown on ambient air quality has found sharp declines in many cities. And this is because their main sources of ambient air pollution are actually transportation and industry. And we know because of lockdown that a lot of transportation was halted during 2020. And so from this paper, if you can see the graph on the right here, the purple dots are representing decline. So here, this is representing a 10 or 20% decline in PM 2.5 during lockdown, while the orange and red is representing an increase. And you can see the majority of air monitors here throughout China and Europe and North America are purple, suggesting there was a decline. But in some instances, including here in Chile, you actually see an increase. And so this graph on the left is just showing the relationship between PM 2.5 and changes in movement. So as the movement decreases, so as you go further to the left on this graph, a higher decline, you'll see that PM is actually lower, which is here in the green. You can see kind of a minimal negative slope. And so this is what other research has shown. But what I wanted to do in this study was look at whether the effect of COVID-19 lockdown may be different given the different source of air pollution. So for the measurements in this study, we measured PM10 and PM 2.5 using 2 different instruments. One was a reference grade monitor called a beta attenuation monitor, which I have here in this picture. And this is run by the Ministry of Health in Chile. And additionally, we used low-cost sensors that were supported by Universidad de la Frontera in Temuco. And so they had a dense network here that actually provides real-time data to the citizens, which is very useful. And so I have here, you can see this screenshot of the Google Play Store. You can actually just get this app for free. It's called Aire Temuco on the Google Play Store. And you can actually see what the air quality is in real time. And then they have different other functionalities of the app that can say whether it's safe to go outdoors, etc. And so we were able to use this data to monitor during lockdown. And here's just another output from the app. This is the dashboard. And so they have, basically this was taken at a certain point in time, they have the level of PM 2.5 at a certain monitor. So you could just click on a monitor and it'll show you the PM 2.5 level as well as the moving average. The moving average is quite high, but the decision of whether it's safe or dangerous is based on the Chilean government. So you could see here they have bueno or good or healthy would be below 79, which is still pretty high, but this is based on being below this critical episode level, which I have on the table here, what the government has set. So basically for PM 2.5, it's setting any level below 79 as safe. And so that's why it's here in green. So they've matched their app to the government standards in Chile. And then interestingly, if you just look at a 24-hour period in Chile, you can see that the PM 2.5 levels, which I have here in green, actually vary significantly throughout the day, and that is due to changes in heating. So heating is more common early in the morning or at night when the temperature is colder. So if you look at the PM 2.5 concentration, you can see right around dinner time or once the sun sets around maybe 5 or 6 o'clock at night, you can see this dramatic spike in PM 2.5, and that is when wood heaters are more common. And this is also an output from the Aire app. And so it shows you the changes over time. You could see here during that early evening and late evening that it's in yellow and red more frequently. That's because of the heating. So you could see this wide fluctuation throughout the day. And so for this particular study, we used the 3 beta attenuation monitors, which I have here in red, and then we use 3 from the network that are the most accurate sensors from that. So I won't go into too much detail for the sake of time, but they are shown in the graph on the left. And interestingly, the monitors were placed in different neighborhoods and also in the center of the city, where there's more commercial activity. So this gave us an interesting study to look at how the levels may change in different parts of the city. And so some of the areas, I'll mention here that Padre Las Casas is actually considered part of a separate city down here, but it's kind of a dual city or conurbation between the two. And so we kind of classified these as middle or low income residential based on input from the local research team. And so we had some middle, low income, as well as commercial areas. So going into some of the results from the monitoring. So in the center of the city, so in the graphs here in red is showing the PM 2.5 levels during winter in 2019, and then this blue teal is during 2020. And so this is during lockdown. So Chile went into their lockdown around April, May, similar to most of the world. And so in the center of the city, we actually see a slight increase in PM 2.5 levels. And this is in contrast to many of the other cities where we're expecting declines. But then interestingly, in the lower income neighborhoods, which I showed in the previous chart, there was actually a dramatic decline. And you can see this is especially true during the nighttime hours when you typically would see a peak, but during 2020, it wasn't as high. And we think this is due to these households refraining from heating at a higher rate in order to cut costs, particularly because of the lockdown and maybe a lack of income. And so we see this clear contrast in different areas of the city. And so this is just kind of quantifying in numbers, and I've kind of highlighted key results. I know the table is a bit overwhelming, but I thought it was important just to see this in numbers. So again, looking at the same 3 locations, we have the PM 2.5 concentration here. We look at the percent change each month. This is the mean per month. And you can see here an increase of almost 30% in some months here in the transition period, they called it. So their main lockdown was in April, but then as they were transitioning to less stricter lockdowns, there was still an increase here, while as in the 2 low income residential areas, there was a sharp decline. So it was this clear dichotomy here. Interestingly, we know that PM10, because it's produced, it's because it was reduced less than PM 2.5.
You look very professional.
We think that, I'm sorry, if someone can please mute if they're speaking, sorry. And because PM10 the increase was less than PM 2.5, and we think this is another sign that it was due to wood heating, because the majority of PM 2.5, majority of wood burning is PM 2.5. And I'll get into this in a few slides as well. And so then we calculated something called the fine fraction. So this is the percent of PM10 that is PM 2.5. And so this is another way basically to just look at the relative increase in PM 2.5 versus PM10. And so for these areas, you can see again that the fraction that was PM 2.5 is again much higher in the city centers. This is suggesting that there was higher pollution sources for PM 2.5 than PM10 that was contributing to the increase. So again, this is likely due to more wood burning going on here, but less so because of traditional like industry or commercial activities that may have been going on during lockdown. We think this is because they were going on to a lesser extent. And then here again, this confirms what we were showing in the previous graph, that the PM 2.5 fine fraction, or the fine fraction, was less in these 2 areas quite dramatically again during the evening hours, showing that heating was likely used less in these areas. And then looking at the other monitors as well that we've had, so this is from the beta attenuation monitors. And for these monitors, we had slightly more data. So this starts in March, so before the lockdown. You could interestingly see how it changed over time. So in March, the actual levels of PM 2.5 here were higher. So it was on track to be maybe a more polluted winter because of the climate. But interestingly, during the main month of lockdown, we see that levels are pretty much similar, but then during May, actual levels increased in Las Encinas, which is a middle income neighborhood. And this is in contrast to the low income areas. We think this may actually be due to residents just being at home more in this neighborhood and maybe heating more often. Of course, we don't have data at a household level to confirm this, but it was interesting to see this contrast here about how the levels were actually higher in this neighborhood. And then looking at the other commercial area, it was similar to the city center, where we see slight increases actually during lockdown and throughout the transition period, which again is in contrast to the low income areas. And again, it's higher in PM 2.5, not necessarily PM10, which is giving us more hints that this is due to the wood burning and not necessarily commercial activity. And this could be due to households in the area just being at home more often, potentially. And so again, showing the levels of PM10 from the same monitors, you can see that while in the previous graph, I showed that there was increases in PM 2.5. Actually, PM10 was the same, roughly, or in some cases slightly lower. So again, this is showing that the PM 2.5 increased more than PM10 for the most part. And so looking at this data, this is again the hourly fine fraction. And this is looking historically from 2017 through 2020. So we had 4 years of data, because these were monitors that had more data by the Chilean Ministry of Environment. And so looking at 2020, which is here in purple, you can see that the fine fraction was much higher relative to other years. Particularly,
you have 5 minutes.
Okay, thank you very much.
Minutes left.
You could see here that the fine fraction was much higher and actually like kind of reached saturation at about 100%, meaning that nearly all the PM was PM 2.5. And you can see this is most pronounced like during the most strict lockdowns, because in August and September, the lockdown started to be eased even more. And this trend is kind of similar throughout, that in 2020, the fine fraction was pretty high and one of the highest out of the 3 years. And so I haven't presented data in this for the sake of time, but we also did a comparison looking at heating to see if the temperature may have been, let's say, colder in 2020 relative to other years. That may explain this, but we actually found that it wasn't, and we controlled for that, which I can get into detail later if there are questions. So to conclude with some of the findings, so we know from all our experiences the past year that there's been a lot of negative downstream impacts, and then focused on household energy, we think that the use of wood heating was likely even lower. As I mentioned at the beginning, that we know because of the inability to afford or to want to save money on your heating costs, that households will refrain from using wood. And we think that might have happened to even a higher extent during lockdown because of some economic instability. And so we focused on 2 of the low income residential areas where we had air monitoring. We know that those have social housing and then therefore may be more vulnerable to the impacts of lockdown. And then other studies have reported, as in many countries, that over half the population has experienced income declines. And interestingly, another feature that I'm sure some of you may be aware with as well, is that mobility was reduced to a lesser extent in lower SES areas. So a couple studies in Chile have shown this. And so their conclusion was that because of the high informal sector or informal workers that rely on daily wages, that they may not have had the opportunity to quarantine as much because of their need to generate income for their family. Maybe that may have also partially contributed to the lower rates because they maybe still had to, I guess, not follow quarantine or state quarantine because they needed to continue their income. So they may not have had that luxury in some places. But as I mentioned, this was more just a quasi-experimental study. We didn't use household level data. We were just comparing the differences between the monitors. And then just to put this in context with another study that has a high informal sector. So in Nairobi, Kenya, some research related to household cooking found a similar trend during COVID-19 lockdown. Here on the graph on the left, this is showing consumption of LPG, which is a common cleaner cooking fuel there. And you can see that those that reported no income coming in versus no change in their income actually reported less consumption before the lockdown. So the point of this graph is to show that the disproportionate effects on the lowest income households that was evident. And in Nairobi, in an informal settlement, we saw a large rate of switching from LPG to wood, which may be a similar cause due to income. They were forced to switch to wood that can be gathered for free instead of paying for LPG, which is a cleaner fuel. And so I'm running out of time, so I'll just briefly go through this, that there was existing policies in Temuco. There are atmospheric decontamination plans and stove changeout programs. But the main point is that that hasn't really reduced exposures to safe levels yet, and there are impacts on deforestation. And because of improved economic activity and population growth, that the rate of use of wood may actually be slightly increasing, and so the impacts on deforestation. And so the solutions that may be needed as part of this is my last slide, just other clean energy sources such as LPG and the gold standard, which would be renewable electricity to reduce emissions of PM 2.5. But of course, there are the costs involved there. And so the cost of electricity as it stands now would be too expensive. So policies that can make that more affordable may be more effective than just existing stove changeout programs, which focus mainly on increased wood efficiency, but actually moving towards renewable energy, which is the focus of the Chilean government, particularly with solar energy. So you can see here that the impacts in terms of on energy poverty and reduced household air pollution would have great benefit. So I'll end there. Thanks very much, and I'll be happy to answer any questions.
Thank you, Mati, for the nice presentation. So now I invite Patrick for the discussion.
Perfect. Matthew, can you stop sharing so I have some slides I'll share. Oh, perfect. Oh. Thing. So. Sorry, guys, hang on a second.
No problem.
This works now. I guess I have to. Awesome. All right, so this was a great paper. I do a lot of work on air pollution, and I've seen a lot of the work on showing that COVID reduced air pollution around the world that you mentioned. I hadn't seen anything like this that suggested COVID increased air pollution. I think that your intuition here, though, is completely right, and it's a really nice illustration of that intuition. So briefly, just to review, I find this helpful in discussants. You look at how COVID impacted air pollution, looking at monitors in several areas around Temuco. A benefit or a nice feature of the study is that you have some heterogeneity in the neighborhoods. So you can see how this varies across different neighborhood incomes, which I think is a really important feature of the study. I guess I probably wouldn't have thought initially that you find the pattern of heterogeneity that you find, but in hindsight, it's super intuitive. It makes a lot of sense. And I think it contrasts really nicely with that existing work that I mentioned and that you mentioned as well, that finds that COVID reduced air pollution in lots of other places around the world, and highlights that these kinds of shocks have very heterogeneous effects depending on the nature of the sources of pollution and the nature of production in the places that are exposed to a shock. And I think that's true not just of COVID, but it's true more generally when we're thinking about how economic or other shocks are going to impact environmental conditions. It's really important to think carefully about what the baseline conditions and the location that experiences the shock are. So a couple questions, and like I said, I thought this was a really nice paper, so I think some of what I'm going to say here probably won't affect the paper itself, but I think might be interesting avenues for future research. There's a line in the paper about how housing construction is a problem because the houses aren't well sealed, and so that allows the pollution to get out of the houses when you use wood to burn or to heat. It seems like that might not actually be what's happened. Like the smoke is going to get out if you have a chimney anyway. The issue with emitting the pollution doesn't seem so much that the houses aren't well sealed. But that kind of leads into the next point, which I think is a really interesting question, is if these houses are not well sealed, then what does that mean for infiltration? So all of your monitoring stations are measuring pollution outside of the homes. That's not necessarily what you were exposed to, particularly during a COVID lockdown, if you were spending most of your time indoors. And I realize this is a much harder question because it's a lot harder to observe pollution levels inside of a house as opposed to out to the outdoor monitors that you have data for. But I think it's a really important question when we're thinking about what air pollution means for health exposure, to understand how much this outdoor pollution that we can measure easily is infiltrating the homes. And I think that fits very nicely with the theme of heterogeneity that you had in the paper, because you would expect you might expect that the sort of level of sealing in a home varies with the income of homeowners. And so in addition to lower income areas, not necessarily in this result, but in general, lower income areas experiencing more air pollution, they might actually in reality, experience or the sort of lived experience is going to be a lot higher air pollution because the infiltration is much higher in lower income neighborhoods than in higher income neighborhoods. And so I think trying to understand that is a really interesting question that this sort of this project suggested to me leads nicely into. You didn't mention this so much in the talk, but you did talk about it in the paper. Pollution and cold both harm health. We know that from a lot of existing work. And so there is a trade-off, as you mentioned, between increasing by burning this wood to heat your homes and reducing exposure to cold, but then therefore increasing pollution versus not burning, not increasing the pollution, but then being exposed to cold temperatures. That's absolutely right. I was a little bit curious of what the relative magnitudes are and how we should think about that trade-off. So what is one way to think about it would be how much pollution is generated for increasing temperature by 1 degree, say, and what does that 1 degree increase in temperature mean in terms of reductions from cold related mortality and morbidity. It would just be nice to try and understand what the total effect was of reducing pollution versus increasing morbidity and mortality from cold. I was wondering, you talked about this a lot more in the talk. I think one thing you could do in the paper to clarify a little bit is the distinction between PM 2.5 and PM 10. It comes out a little bit in the paper that you want to understand. You're looking at those differences to understand the sources of pollution, but I think you could make that a bit more clear. You also do observe some increases in PM10 levels, and given that a lot of the pollution from Temuco, as you say, is coming from burning wood, I was wondering if you have an explanation for what that increase in PM10 or what might be driving that increase in PM10. And then the last thing, there's some heterogeneity in the results that I think you don't fully explore. In particular, your pattern of results, you mentioned this in the paper, high income areas see larger increases in the evenings and the mornings in 2020. And commercial areas also see increases. And it wasn't totally obvious to me why. My intuition would have been if people are burning more to heat their homes because they're staying home during lockdown, you would have seen the largest increases relative to a baseline in which they're not staying home in the middle of the day when they were less likely to have been home prior to the lockdown. And so understanding what's going on there, I think would be interesting. And then just a little bit more discussion of maybe there's something about the residential makeup of commercial areas in Temuco. But as an outsider, I didn't quite understand why we would expect to see increases in pollution in commercial areas during the lockdown. And then just a couple of
we are running out of time, Patrick, so probably you can send.
I was just going to put the minor comments up and then open it up to other questions. I know Mook has a question that I would also be curious to hear the answer to.
Okay. So Matthew, you can answer selectively the questions and probably the question from Mook as well.
Great. Yeah, there was a lot there. Thanks a lot for all those thoughtful insights. It'd be helpful to have your slide again. I was trying to go through them. I didn't have a chance to write them all down. So
I'll send it to you.
Okay, yeah. So I'll just try to go off of memory. But yeah, you provide a lot of insight into like future studies. So I don't have a lot of that data now, of course, but I think there's a lot of research there in terms of infiltration. It's been done in other parts of the world, but like you were kind of getting at that, that's not the full solution, right? If we just seal off households, that's not going to solve this problem. It's kind of just these marginal solutions as like one way, but as I think we agree on, you need to kind of focus on more just reducing the pollution itself. And so in terms of the differences in PM 2.5 and PM 10, I think, and again, this is all speculation because we don't have the actual household level data, so that could be another study in itself, is just looking at those patterns. So I don't want to say, I'm going to say this is not for certain, but the increases that you say during the middle of the day, but heating may not be used regardless if they're home during the middle of the day for various reasons. So in that case, we may not see those large increases. It's not certain exactly, if the households were completely confined to their households. Chile did their lockdown slightly different, which I didn't get into, but they kind of had these localized lockdowns where you couldn't really move outside of a certain area, but I think they were still allowed to go outside their homes. Potentially they didn't want to heat, during the entire part of the day. But it was interesting about, you mentioned like the PM10 increases. And so my initial thinking, again, this is speculation, was that 2019 was actually a slightly warmer year than 2020. And so we were comparing them, and I didn't include this analysis like in the actual slides, but I wanted to focus on the PM fine fraction between 2017 through 2020. But the slight increases in PM10 may be due to the colder temperatures that did facilitate more burning. So even though the majority is PM 2.5, there is still some PM10, but then I know we kind of just simplified it to just like commercial versus residential, but there is some mixing there in some cases. So there may also just be some wood burning, but I guess for simplification, for the purposes of this study and this talk, I kind of did that. But I mean, you pointed out some great nuances there, and I think you gave me a lot of good ideas for kind of explaining that in the discussion. So I appreciate that, and I'm happy to discuss more, but for the sake of time, I'll maybe answer someone else.
Yes, you can reply Mook's question through the text. So we are running out of time. So
okay.
Yeah, so you can reply by text. So thank you very much for the discussant and for Matthew. So now we move to the next presenter. You can